So let's get started learning how to name things. This is a naming flowchart we were going to be using in class. I know it looks very big and a little overwhelming, so don't panic. We're going to take it one thing at a time and then we'll put it all together at the end. Right now, we're just going to focus on the covalent portion of the flowchart. Okay, so how can we tell something is ionic or covalent? Well, if there's a metal, simple as that, it is an ionic compound, or if it has ammonium as the first thing, NH4 plus. If there are only nonmetals, it's a covalent compound. It's a molecular compound. So we're going to start with naming molecular compounds. But before we do that, we're going to, there's a few molecules that you need, compounds that you need to know. Actually, they are all molecules that you need to know their common name because it's so much easier to just call them by their common name and everyone uses them. So you need to be aware of them. Most of them well, at least one of them you know. The other two you might know already because I mentioned them a lot in class so far. There is water. It is the common name for H2O is water. The scientific name is dihydrogen monoxide, but we don't use that word. We don't use that name. CH4, which is your natural gas, which you use for cooking with, is called methane. So if we were to use covalent naming rules, this would be carbon tetrahydride. Methane is the correct name for it if you're using organic naming, hydrocarbon rules. And then you have ammonia, NH3. The scientific name would be nitrogen trihydride, but everybody calls it ammonia, so you must be aware of that as well. So let's talk about naming molecular compounds. In other words, naming molecules, naming covalent compounds. So I'll just remind you what a covalent compound looks like. Water is a covalent compound. You have electrons shared between your elements. So you form a bond with a shared electron. This hydrogen is sharing its one electron with oxygen in order to achieve two electrons around itself, which is what it needs. The same is true for hydrogen here. And when those two hydrogens share their electrons, now oxygen gets an octet and it is where it needs to be. So that is the whole benefit of sharing electrons is that they reach an octet, or in this case, hydrogen reaches 2, which is what they need. So when we are naming our molecular compounds, remember our molecular compounds don't contain a metal, they contain covalent bonds, and when we name them, we are going to use prefixes to name your molecular compounds. We will only use prefixes for covalent molecules. You will not use them for ionic. This is only for covalent. Remember I said the rules were different, whether it's covalent or ionic. Here's where they're different. Prefixes only go for molecular compounds. You know many of these prefixes already, and you'll notice that when I show you the prefixes. So the prefixes we use to distinguish molecular compounds are the following. If we have one of an atom, it is mono. Like a monocle is one lens. Mono means one atom. If we have two of an atom, we call it di, not bi, di. If we have three of an atom, we call it tri, like a tricycle, tri. 4 is tetra. That was a little odd. 5 is penta, like a pentagon. 6 is hexa, like a hexagon. 7 is hepta, like a heptagon. 8 is octa, like an octopus or an octagon. 9 is nona. 10 is deca, like a decade. These are the prefixes that you will need to know, so you need to have those memorized or written down or something like that. So why do we need to have these prefixes? Well, for instance, nitrogen can bond with oxygen in more than one way. So if we're talking about these different molecules where nitrogen and oxygen are bonded together, we need to be able to distinguish between them. So for instance, nitrogen can bond with oxygen where you have two nitrogens and one oxygen. Dinitrogen monoxide. This is laughing gas. This is what you get at the dentist. NO2, nitrogen dioxide. We need to be able to distinguish between these two. This is a component of smog. It gives you beautiful sunsets, but also gives you that brown haze you see in the sky over cities. We have N2O2, we have N2O5. They're bonded all differently. They're all covalently bonded, but they're bonded in a different ratio. But we need to be able to distinguish that, and we use those prefixes to help us distinguish them. We say that this guy has 2 nitrogens, but this guy only has 1, and we say that in the name. So here comes the rule. So to name a binary molecular compound, you're going to name let's look at the first element in the formula. So let's go to that N2O, that laughing gas. We're going to write down the name of the first element in the formula. For N2O, the first element is nitrogen. We're going to write down that full name, nitrogen. Then we're going to see how many of those elements we have. So if we're looking at N2O, we have 2 of them. What is the prefix for 2? That is di. So we would say dinitrogen. So we're going to add prefixes to signify the number of a specific kind of atom we have, only if there's more than one of the atoms. In other words, we're only going to use prefixes di through deca. We will not use mono for the first element in the formula. Okay? So for N2O, it's dinitrogen. That's the first part of it. The second element in the formula always gets a prefix. Doesn't matter if you have 1, 2, or 10. You always give a prefix. So the second element, if we're looking at the example of N2O, the second element is oxygen. Okay, we said N2O, so 1 oxygen. The prefix for 1 is mono. So we'd say dinitrogen mono, and then we're going to take the first syllable of the name of oxygen and change the ending to "ide." Dinitrogen monoxide. Now let's do this for NO2, the one that's the component of smog. NO2, first element is nitrogen. So we write nitrogen. Then we see how many of those nitrogens we have. Oh, we only have 1, NO2. So we don't use a prefix there. Look at the second element. Second element is NO2, O2. You have 2 of them, so that's a dioxide, nitrogen dioxide. Okay. Now let's look at our flow chart so you can see how this flow chart works. I've blocked off all the parts that are not relevant right now. So we're going to start with the flow chart. First question the flow chart asks you is there a metal in the compound? And I'd like you to make a change to your flow chart at this point. I'd like you to write, is there a metal in the compound, or NH4 plus, or NH4 plus. Okay, is there a metal or NH4 plus? And you're going to say no. Then it's going to say, is the first element hydrogen? In this case, no. If it's hydrogen, it would be an acid, and we'll do that later. No. Now we're going to count the different number of elements. So if you only have 1 element, that's your diatomic. Those are the 7 diatomics that you need to memorize. So if you have like a Br2, an I2, an N2, a Cl2, an H2, O2, or F2, you will just name that element by its name. So Br2 is bromine. I2 is iodine. Remember, these are the guys that don't like to exist by themselves. If they can't bond to something else, they will bond to themselves because they don't like to be by themselves. Okay, so if you have 1 element, you're a diatomic. It's only going to be one of these 7. If you have more than 1 element, in other words, 2 elements or more, that's called covalent binary, and you're going to name the first element first using prefixes with the exception of mono, and then you're going to name the second element using prefixes and change the ending to "ide." Those are the same rules we went over, but right now it's in the flowchart. So let's do a couple of examples. Okay, Cl2O8. We have 2 chlorines. The prefix for chlorine for 2 is di, so we write that first. And then we write the name of the entire first element, chlorine, dichlorine. Now we look at the next guy. The prefix for 8 is octa. And then we have an oxygen. We're going to keep the first syllable of oxygen and replace the rest of it with "ide." So this is octoxide. Now, if you notice, it's octoxide. It's not octaoxide. We try to not have double vowels if we can avoid it. Okay, so that's dichlorine octoxide. Now let's look at this guy, PCl3. We're going to write the full first name of the first element, so it would be phosphorus. And then we look to see how many of those we have because we need a prefix. Oh, we only have one. When you only have one, you don't write down mono. You just write down the name of the element. So that's phosphorus. Now let's look at the next guy. This is a chlorine. How many of them do we have? 3. The prefix for 3 is tri, so you write tri. You're going to keep the first syllable of chlorine and replace the ending with IDE. So this becomes phosphorus trichloride. So let's try another one. Try a few more. So why don't you pause the video right now? Try these 4 and then unpause and I will show the answer. Okay, welcome back. First one, 2 sulfurs, 2 chlorines. This is a disulfur dichloride. 2 sulfurs, 2 chlorines, replace the ending with IDE. 1 boron, 3 fluorines. Boron trifluoride. Replace the ending with "ide." There is no mono in front of this word because we don't need it for the first element. Dichlorine monoxide. 2 chlorines, 1 oxygen. No double vowel. Diphosphorus pentasulfide. 2 phosphoruses, 5 sulfurs. Replace the ending with IDE. Okay, the next step is now if I give you the name, can you go and give me the formula? So instead of just now I was giving you the formula, I wanted you to give me the name. And now we're gonna go in the reverse direction. This is simple. If you know your prefixes, then it's very easy to figure out the formula from the name because it tells you the name, it tells you exactly how things are bonded. So just to remind you, these are your prefixes. Your prefixes help to distinguish your molecular compounds. Mono 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. So let's practice. Carbon tetrachloride. So first element is carbon. Let's write down the symbol for carbon. That is C. How many carbons do we have? Well, there's no prefix in front of it, so we must only have one. So we have a C. Tetra means 4. Chloride comes from chlorine. That means we have 4 chlorines. The symbol for chlorine is Cl. So we're going to write carbon. So C, Cl. How many Cls? 4. Carbon tetrachloride. CCl4. Nitrogen trifluoride. We have 1 nitrogen. There's no prefix before it. We have 3 fluorines, NF3. Okay, let's practice another step. Right now, why don't you pause the video right now to practice these? And I will come back in a minute and you can see the answers. Okay, welcome back. First one, iodine heptafluoride. 1 iodine, 7 hepta, 7 fluorines. I of 7. Dinitrogen pentoxide. 2 nitrogens. Pent means 5, no double vowel. Pentoxide. 5 oxygens. N2O5. Carbon tetrafluoride. 1 carbon. Tetra means 4. Fluorides 4. 4 fluorides. Carbon F4. CF4. Last one, silicon dioxide. 1 silicon, 2 oxygens. SiO2. It is that simple to do covalent compounds. The biggest issue is forgetting that this only applies to covalent compounds. We will not see prefixes anywhere near your ionic compounds at all. Keep that in mind. This only applies to covalent compounds. Next up, naming ionic compounds.